Hi everyone, welcome back to the series where I talk about the brain facts book to explain the concepts a little bit more in depth. Okay, so the first thing we're going to talk about today is known as the nerve tracts. So as you can see here, when the brain receives a stimulus, it needs to be able to communicate with different parts of the brain. So for example, when your eyes receive information, you have so many aspects that need to be processed. For example, where the object is, or what's happening to it. Is there sound coming from it? Is it a different so just in that piece, you have to communicate with different parts of your occipital lobe, like V4, which processes color, and V1 that processes lines and orientations to put together a collective image and to be able to send it to different parts of the brain, like the temporal lobe, to actually identify what the object is. So for that, you need to have what enables this communication. So these communication happens through things called nerve tracts. So the nerve tracts are basically axons of neurons from one region to form a bundle to connect with other regions. So basically the axons, and more specifically the myelination around the axons, are known as white matter because when you look at it through a scan, they appear white because of all the myelination around it, right? So basically, what these do is they link one region of neurons to another. That's what nerve tracts are. They're a
Okay,
bundle of
I
axons
found this
that
on the
come
web, or
together.
is it a different
Sorry,
color code?
I'm so sorry. That was Siri. Anyways, um, basically, what these do, right? These are tracks that connect one region to another through the axons. So yeah, as you can see here, there are so many different nerve tracks, but the most common one I'm sure you've all heard about is known as the corpus callosum. So that's basically like the thick bundle that connects both hemispheres of the brain. What it does is it connects like different regions, corresponding regions from both brains. Um, Basically, you've also probably heard of the anterior commissure. So the anterior commissure runs from both the temporal tracts, as you can see here, and it connects the regions of the temporal lobe. And there's also a posterior one, and there's cortical spinal tracts that we'll talk about later. And I think the one that we all can actually understand the most are optic radiations, right? So in the visual system, you will learn a little bit more about this, but the information that your eye receives will go to the thalamus, right? And once it goes to the thalamus, it needs to somehow be sent back to the occipital lobe. The thalamus, if you look at it from an axial view, you can see there's quite a bit of a distance. But how the information gets there is through nerve tracts. You'll see little curves that'll come out of it. If you Google it, you can see optic radiations that are coming through. They literally look quite distinct if you look closely. And the reason for that is they send the information to there, right? And so basically, there are different types of nerve tracts. First, there's association fibers. So basically, it's the same cerebral hemisphere, just in different regions, right? So that would be something like optic radiation. So if you receive information in the right thalamus, and the optic radiation send it back to the right side of the occipital lobe. Those are association fibers. Then there's commissural, which basically are different hemispheres but connecting the same region. That's what anterior commissures are and posterior commissures are. It connects the same part of the temporal lobe on one side to the same part of the temporal lobe on the other side. Then there are projection fibers, right? These are basically in the cerebral cortex and connect them to different deep brain structures. So the best way to explain that would be the basal ganglia system. So basically, the basal ganglia is a way that is the part of the brain that controls voluntary movements. So as just a brief overall explanation, in the brain, there is your motor cortex, which elicits movements. It starts movements, right? So what happens is that inside the brain, that's the midbrain, right? It's not, you can't see it in the top, but it's inside the basal ganglia. The motor cortex will send it to the basal ganglia, which is mediated through a projection fiber, and the basal ganglia decides whether it wants to let the movement happen or not let the movement happen. If it wants to let it happen, it'll signal dopamine. If it doesn't happen, then it'll signal less dopamine. And based on the threshold of that, the basal ganglia will send it back to the motor cortex. And if it's a yes, then the movement will happen. If it's a no, then the movement will not happen, right? So through projection fibers, different regions of the brain can communicate. They don't have to be in the same cerebral cortex. They don't have to even be in the same hemisphere. They can be in completely different hemispheres, but they can still communicate. So that's my video on nerve tracts. If you have any questions, please feel free to email me. And yeah, thank you so much. Bye-bye.